Thank you for being here. This is my talk, Hacking Kubernetes for Fun and KWasm. I got another subtitle yesterday since Civo announced that they will integrate WebAssembly in their Kubernetes clusters. You can see a glimpse of the future today with manually adding a WebAssembly runtime to your Kubernetes cluster and getting the same features already now. I'm Sven Pfennig. I'm a lead developer at Liquid Reply. I'm working on hybrid and multi-cloud environments. I'm an open source enthusiast and a big fan of WebAssembly. You can find me on various platforms with my easy to remember handle. It will stay here all presentation long. Besides this slide. Liquid Reply is the Kubernetes and cloud native consultancy of the Reply network. We are also partners of the Green Software Foundation and members of the Bytecode Alliance, and we started a little open source project called KWasm, which you will learn about in a minute. In this talk, we will have a look at what makes WebAssembly containers special. We look at the architecture of a Kubernetes node and what Kubernetes security defaults are about. And then we see the demo, hopefully, with a Civo K3s cluster through our Wi-Fi in the internet with real Civo. So let's start with WebAssembly containers. If you're not familiar with WebAssembly, I put everything you need to know on one slide. No Solomon Hykes sites here, so only official definition like WebAssembly, Wasm. In this talk, I will only use Wasm. It's a binary instruction format for a stack-based virtual machine. Wasm is designed as a portable compilation target for programming languages, enabling deployment on the client and server for web applications. And I really love this illustration, how the brave little WebAssembly modules make their way from the browser world to the server and are on the server as so on the server it's as missing word. So it's heavily used, like in the browser. The WebAssembly has some unique features that are interesting for server-side development. Speaking of, in Kubernetes, you always have the problem that your images are bigger than necessary, and every base image comes with an overhead. Besides the Scratch image has no overhead, and most WebAssembly containers are directly based on Scratch. You just put your Wasm file in your empty container and upload it to the registry. You don't even need a runtime, because the runtime is already installed on the server, if the node is prepared for that. You can run WebAssembly modules on any architecture, like Intel, ARM, RISC-V when you have a matching runtime. Or Windows, Linux, it doesn't matter. The only important thing is that your runtime works. And they are sandboxed by nature. So you have always to say which permissions your module is allowed to use. Otherwise, it's denied. And you can already use them today. With the latest version of Docker Desktop, you can go to your settings and activate WebAssembly. It downloads the so-called container edition. And Azure AKS has a fuzzy node pool preview. With that, you can already run WebAssembly containers on your AKS cluster. And soon you can do the same on Civo K3s. So, since I'm a multi-cloud consultant, most of our customers have not one cloud vendor, but multiple of them. And we thought, why should you log into a single cloud provider when you want to use WebAssembly images? Why not use all of them? And that's why we came up with the KWasm project. So the basic idea is bringing the capabilities of running WebAssembly modules to basically any Kubernetes. At the moment supported are several local Kubernetes distributions as well as some cloud providers where AKS and Civo soon can run it natively, but you can always update the shims with the KWasm project, since the shims are developing faster than the cloud provider updating their images. Let's have a look at the architecture of a Kubernetes node. So that is our Kubernetes node. On top is a kubelet. The kubelet registers at the control plane and communicates with the control plane. On the node, it has the so-called CRI, the Container Runtime Interface, which is usually implemented by Containerd or CRI. Then there is the low level, the OCI runtime. The OCI runtime, for example, is runc, crun, or uki. And then there is this little piece between the CRI and the OCI runtime, which is called a shim. All of them can run containers, and at the shim we have a closer look. So your CRI will start a shim when you start a container. This is a little bit simplified. The shim starts a shim daemon, and the daemon then starts your lower level OCI runtime, which then starts your container process. This is that your container can outlive a restart of your container runtime interface. So your container runtime interface, like Containerd, is restarting, but all of your pods, of your containers in that pods are still running. They do whatever they do, and if the CRI comes back, it can still communicate with your processes. Let's have a zoomed-in look on Containerd, because most of the development of the Wasm shims is happening under the umbrella of Containerd. I've chosen these two runtimes because they are so flexible that you can compile it with WebAssembly support embedded. That means you can run your WebAssembly containers with those OCI runtimes without changing anything in the stack. Another option is to build a so-called Containerd shim, which is not a shim that calls an OCI runtime, but has a WebAssembly runtime baked into the shim directly. In this case, it's the Wasm Edge runtime. But you can also do, for example, the same with the spin runtime from that runs the spin from Fermion. And there are a lot of other runtimes. If you want to talk about runtimes, you can come here later and we can talk the rest of the day about runtimes. All of them have special features and use cases they are specialized in. And some of them are not released yet. For example, Wasm is an open PR, so it still needs some time till it makes it's into the Containerd run RASI repository. Yeah, all of them are possible extensions for your Kubernetes cluster. But how to install such a shim? Containerd is usually looking for shims in the path. If you have an runtime registered for IO Containerd spin v1, here it is spin, here is the name, okay. Then it looks for a binary called Containerd minus shim minus v1. With just putting it in the path of your VM, it's already possible to run Containerd with CTR and start your WebAssembly container. That's great. You just need to move the binary onto your node. When you are using Kubernetes, you need a runtime class. So a runtime class is looking like this manifest, and you specify there which runtime to use. Unfortunately, you can't use dots in a runtime class, which means you need to have an alias in your Containerd config. That's why we are adding this snippet to the Containerd config, restarting Containerd, and we are basically done with installing a shim. Sounds easy. So let's have a look at Kubernetes security defaults, because we are starting a managed Kubernetes with Civo, and there is no option change my image I want to have something in the container dconf and a binary on the path. So you might remember the 4 C's of cloud native security from the Kubernetes documentation. So the inner layer is the code, then we have the container, the cluster, and then the cloud co-located data center or corporate data center. It just needs to be a C, otherwise it would not be 4 C's. We don't need to care about the code and the container because that's our responsibility. We can just start any container we want. But we want to modify the cluster, namely the node itself, so the worker nodes at least. So we somehow need to cross the boundary between the container and the cluster. Generally, containers are not perfect sandbox by intention. So you can configure them that they isolate your workload with setting security policies, not running as root, and so on. My colleague Christoph usually says default Kubernetes configuration is an open barn door. And it is like that. So you can by default just run privileged containers and do whatever you want. That means, so I don't know when the last time you just have called something and piped into your shell with root privileges to install the software. When you do a Helm install with a Helm shard somewhere in the internet, it's basically the same, but for all of your nodes. So it can just do anything on all of your nodes, just as a reminder. When you're doing that with KWasm, we have good intentions, so that's a good thing, just using Helm and install KWasm. But for every other software, you should be careful. How do I get root access when I'm starting a container? This is a manifest where you have, for convenience, I have mounted the root path of the host to my container, so I can easily copy over binaries. And we have, where is it? Host pid true and privileged. So this is the most mighty container you can start. And you can then copy over things to the node, and you can just restart processes. Or you use a convenient node shell plugin for your kubectl. So it does all the things for you. Log into the host of the container, and you can have a shell on the host. Let's go to the demo. Okay, I guess I need to increase the screen. Can you see it? Still a little more. Okay, I think it's not possible to increase the size more. So, I'm logging into a cluster I've created previously. I look at the nodes. I have 2 nodes, the cheapest one, and then I just use kubectl, node shell, and enter my node. Now you need to think of a 90s hacker movie where I say, okay, I'm starting a super privileged container. It's doing a container escape, opening a shell on the host, and oh, that's tough. I'm in. So now I'm on the host, and when we look at the processes, then we see here the ns-enter that brought us to the host. So it's no magic. We are just using the admin privileges we already have, and with this ns-enter, we change the namespace of our container to the outside world. Now I'm on the node, and I can just do something like this prepared curl that just downloads me the Wasm shims from the Days Labs repository the one I've shown before. It's the one on the bottom that contains the spin shim, which we are going to install. Since this needs a moment, we can just go to the official repository and see what's needed. So here are the same install instructions. That is what we need to add to the containerd config. After that, we add a runtime class, and here is a deployment with the spin pod with the Hello World applications. So it still needs a moment. It stopped? No? Okay. Let's put it in a background and continue. A little thing you need to know about K3s is that K3s has a configuration file for containerd. It's under K3s, so var lib this path. But when you restart the K3s, it's looking for the same file but ending with template and overwrites this file. So that means when you do changes to your config, it doesn't matter after restart. If you're changing the template, that's okay, that persists. Permission denied? Oh, I only copied the half. My bad. So, let's go in here. We copy over our definition for the alias that the spin is mapped to IO containerd spin v1, which leads to that containerd is searching on the node for containerd minus shim minus spin minus v1. Okay, that's basically it. Now we can, oh, wait, little thing, we need to restart containerd. Otherwise, it doesn't have an effect. Civo nodes are not based on some Debian systemd distribution. That means we need to go to etc. I have an init script for K3s. And we say restart. We now say stopping K3s. We don't need to wait for starting K3s again because containerd is gone. Our connection was through containerd, and this connection will time out in a second, minute, I don't know. What's next? Let's create a spin service. QCDL. I would just copy and paste the example, paste it here, and the pod, which is looking like that. So we are pulling an image here. The command is just slash. It's a special thing for spin images. It just needs a folder where the spin.toml is located. And that's it. Let's see what's happening. Okay. That's not looking good. When we see, oh, we need to go to the replica set to see what's happening here. Successful, successful. Let's see at the pods. And that's the moment where we see failed to create sandbox, failed to, and so on. Spin is not configured. When you do it manually, you need to do it for all of the nodes because there's still a node that is not configured. When we go to the deployment and just scale it up, then we see that hopefully one of them is landing on a node that is provisioned and we have a running spin service. To demonstrate, I just use a port forward 80 to 8080 and on localhost 8080 we get a 404 because that's the application. And when we go to hello from Spin. Yay, we started a container. We customized our node. Okay. So, oh, I still have 5 minutes. That's great. I would just do the same. kubectl and switch the context to KWasm. Oh, wait. I need to get the credentials first. So I have prepared another cluster. It's called KWasm on Civo. You see there should not be any Spin application running. And we are doing the same with installing the KWasm operator, which is installing an operator. The operator is creating jobs. The jobs are super privileged. These jobs go on the node, copy the binary over, change container D config, restart container D, and you're basically able to run WebAssembly images. Wait, runtime class. Deployment. Here you already see the install job, which is already done. And our application, which should start in a second. Interesting. Am I on the right cluster? No. Live demos. I'm sorry for that. Just imagine it would have worked. It usually does. Okay. So, what's next with the KWasm project? There is a proposal from David Justice from Microsoft to make it a lifecycle manager for shims, so that you can just create CIDs like enable Spin, enable Lunatic, enable Wasm, and it provisions your nodes as you need it. There is the 0.9 release of the shims, which is 2 days old, and it has the capability of running WebAssembly with sidecars. So you can use Spin with Dapper, you can have it in a service mesh. All patterns we are currently using in Kubernetes world are now possible. So that makes it applicable for real life use cases. And Lunatic and Wasm are just joined or about to join the party, and you can create your own container D shims that are doing this. If you want to get in touch, we have the KWasm channel in the CNCF Slack. You can go to kwasm.sh or you try it yourself on Killer Coder. So there you get a Kubernetes cluster. You can provision your Kubernetes cluster with the operator. You are guided by the Killer Coder interface, and then you can play around with it and see which runtime suits you best. Are there any questions? Yes, please. Oh, wait, I was told that I need a microphone, otherwise on the recording it's not hearable.
Hey, I'm not sure if this is a silly question or not, but is the main benefit that you would have of running the WebAssembly containers that you'd like be much more efficient in your cluster in terms of like the size of stuff or overheads of things, or is there some other benefits that it also would give you?
Really good question. So with WebAssembly images, they are smaller, so you don't need that much bandwidth. You are sandbox, so when you go with security in depth, you have another layer of security around it. You have a path towards WebAssembly applications without re-implementing your whole application. So you can say running in parallel, you are slowly shifting over and then running on other services. It's more performant depending on where you start. When you have Python applications or you have Node.js applications, it is more performant. If you have Rust applications running in WebAssembly, you have this layer on top, so it's a little bit slower, but it's really, really close to native. So when you think about other technologies. More questions? Thank you. So, yeah, anytime. If you have a question after.
So, how would you advise troubleshooting of Wasm in a container through time? Because it makes sense when you deploy something in production and you really don't want anything changed at all. But it's going to be really hard for somebody else on a staging environment, for example, to just fiddle with your code base at some point and see the result.
Excellent question. So there are multiple approaches. So what I would advise you can do already is just having endpoint for your liveliness probe, readiness probe, Prometheus metrics, open tracing, and so on, that you go the cloud native way, use the cloud native tooling, and use it for debugging. If we're talking about real debugging in WebAssembly application, which means connecting to the runtime with a debugger, it's hard right now.
So what to do?
But in the end,
So what to do?
What to do? You can do the tedious work and get somehow a debugger to run. In the end, it's just a Linux process, which means you can, when you can use one of the sidecar-enabled runtimes, you can start a debug container, so an ephemeral container, connect to your runtime, and do a remote debugging session. It's nothing that works out of the box.
Is there anything in the roadmap related to this? Because I think it's a really huge downside for the experience.
There are people working on that. It's a problem for some years now. So proper debug tooling, if you want to have a project, an open source project that really gains traction, do WebAssembly debugging tooling.
Yeah, I mean, you can use WebAssembly in production, for example, and use typical containers on staging, for example. They just slightly aggravate the experience. Well, in a platform engineering thing, they just basically support two targets, depending on the environment.
Exactly, but the problem is connecting the debugger to the runtime.
Yeah.
No matter if you have a container or using the runtime standalone.
Yeah, you're
right. Just hypothetically speaking, if you have 100 nodes running or more, what is the right way to roll out the Wasm runtime into all of them?
Question was how to get to runtime into the container as a shim?
No, into nodes, right? Because you have to.
Good.
No, because like you use the KWasm to, or sudo root access to install the Wasm runtime on container D, right? The shim. If you have hundreds of nodes, you're not going to do one by one, right? You're not going to go into each of the nodes and install. Like, what's the right way to roll out the Wasm shim into all of your nodes?
Absolutely great question. So if you are a cloud provider and you set up your nodes on your own, just bake it into your image. So it's just there. If you are a cloud user and have hundreds of clusters or hundreds of nodes, then you can use the operator. The operator installs it on every node. So that was the unfortunately not working example. So it would have provisioned all of the nodes at the same time.
Would it involve any downtime of existing containers, or because it restarts the container D, right?
It restarts container D. It's usually not more than a flickering on your API server. So you can still connect to your API server. You're starting containers. That is a little bit delayed. But you're right. If you really want to make sure that you have no effect, you can start one after another. You could even do a rolling update, drain your nodes. But in my opinion, that's only for hypercritical workloads. So usually it has no effect on the running containers. So they are running as they do. You don't see them for part of seconds. If there are no more questions, you are still invited to come over, talk about it. And if you are interested in more WebAssembly stuff or how Spin works, Fermion has a booth here. And then thank you for being here.